So we're supposed to use the fundamental theorem of calculus, the first part, in order to evaluate this, this expression that we have here. So what you want to do is use the fundamental theorem of calculus, use like the notation that you've seen, and try to match it up with what we have here. Okay. Now, if we just pretend the derivative isn't there for a second, this looks like f of x, right? Because it says f of x is an integral from some value a to some variable x of some function f of t dt. So we could say our f of t is the square root of 1 minus t squared. It goes on to say that the derivative of this whole thing, which is what the notation here, I don't want to lose that. There we go. It says the derivative of f of t, this whole thing, which is the notation we already have over here, just different notation, right? The derivative of this whole expression is going to be f of, now just a change of variables, now x instead of t. Okay, so they were integrating up to x, and so the derivative was a function now of x. We're integrating up to a function of x, though. That makes it a little bit trickier. We're integrating up to sine of x. Okay, so our function is going to be a little bit different because we have to use the chain rule. Okay, so we are getting f of sine of x, but before we write that down as our final answer, remember when you use the chain rule is applying to derivatives. You take a derivative of the outermost function, which is this big thing, right? But then you have to chain it by multiplying it to the derivative of the innermost function. In this case, we're going to derive this using the fundamental theorem of calculus, but the derivative of sine of x is cosine of x, okay? So this expression is going to have a cosine of x because of the chain rule, and then it's going to be multiplied to whatever f of sine of x evaluates to be. And so this part's just kind of straightforward algebra, right? We're just, well, it's not straightforward, but it's algebra. We're going to plug in, oh, and I lost my square here. We're going to plug in sine of x everywhere where t goes. So multiply sine. And then keep simplifying. That's cosine of x times now 1 minus sine squared. That's a Pythagorean identity. That's cosine squared x. And then if you're trying to evaluate the square root of a square, yeah, they kind of cancel out. But remember, it's not exactly canceling out because whatever comes out of a square root has to be positive, right? So we're going to multiply by the absolute value of cosine of x here. And now we're done. We've evaluated this expression, okay? We saw that this was our capital F. So that means our lowercase f is just the square root of 1 minus t squared. So instead of evaluating up to x, the limits of integration up to x, it went up to sine of x. So that meant we had to plug in sine of x in for f of t. But there was that extra little step that since we're finding a derivative, we also have to take a derivative of the innermost function and chain it on by multiplying using the chain rule.